Then let's go back to our lecture. So this gives you the overall picture of where we are. We finished with the creational, and today we will finish structural pattern. Facade and the Proxy are the last two patterns we discussed in this category. And also today we will discuss the chain of responsibility. Okay, let's look at the structural pattern. We know deal with composition, and we decompose and then put the classes together, and then to change the structure of initial design to serve some purpose. And then we have two categories in terms of implementation, either using either using inheritance or using the delegation. Okay. Let's see the facade. So the context of facade is often usually the application may contain several complex package, and the programmer work with such a package has to manipulate many different classes. So usually when you're dealing with a library or or the third party package, and they provide so many classes, and then to use that package, you must be get used to the package, and then the internal how each class is working and how they interact with each other. But that need a lot of work. However, programmer only need to use a subset of complex system, or they need to interact with system in a particular way. So in other words, the package can be very complicated. You don't have to learn everything. You just need because you only need a partial or very limited function of a complex package. So if still ask you to learn the whole package, that's a waste of time. Then the solution is we can provide a simple interface we call a facade. Is a new interface for the client of the existing system without changing the existing system. Just put a facade on top of it, and that facade is a new interface and will interact with the existing system in a particular way, so that then you don't have to work with the complex package, and then you just interact with the facade. That would be enough. Okay, let's look at one concrete example here. Suppose you have a home theater system, and then it will and it also provide you with a number of classes that interact with the hardware, so that you can watch a DVD and listen to the CD, and also listen to the radio, and also interact with the popcorn machine to make popcorn for you. So from here that we have 1, 2, 3, we have 8. We have 8 classes involved, and then they need to interact with each other to get the required job done. Then let's see how we watch the movie. See the hardware. If we want to enjoy the popcorn, you need to turn on the popcorn machine, and then you need to dim the light, and you need to put a screen down, and turn the projector on, and set a projector input to DVD, and put the projector on widescreen mode, and turn the sound amplifier on, set amplifier to DVD, and then do some setting with amplifier, and then you turn the DVD player on, and then you start to play the movie. So let's looking at if we translate this watching movie step into the source code, then we see that we have 6 different classes involved. We have a pumper, we have a light, screen, projector, amplifier, and we have a DVD player. So here we have 6 classes involved. And then think about that after you finish watching the movie and you want to turn off everything, that's you need to turn off these 6 classes still. So to watching a movie is such a simple request, but we still need to learn 6 classes, learn how to deal with them. And then a new design is when we use the facade, if you want to avoid interact with the system internally, you can think of a new interface we call the facade. And this facade, of course, hold instance variable, and that have an instance variable hold a reference to these 8 classes within the package. And then this one contain the most demanding operations, like watch movie, end the movie, listen to radio, and end the CD, and listen to radio and end the radio. So the most often used operation, and then we can define them in the home theater facade. Then from user point of view, they don't have to deal with 6 different classes. They only need to deal with one class, home theater facade. And then just if a user want to watch movie, just call watch movie operation. Watch movie method in the home theater facade, and home theater facade will forward the request to the corresponding classes inside the package. So similarly for the end the movie, listen to radio, listen to CD and CD, radio and the radio operation. So you will see that from user point of view, the user doesn't have to learn all the classes, how all the classes within the package, how they work, how they interact with each other. They only need to know how to interact with the home theater facade, and then that's enough. Yeah, then they can have their required operation done very easily. So that's the purpose of the facade. We have a simplified interface to a complex package, so that user can interact with a compact package easily. So this just we say that we solution is create a facade, so that client code just need to interact with the facade. So this gives you the differences of using the facade and without using the facade. So you see on the left-hand side is a client class. Without introducing a facade, it has to interact with the package class directly. Yeah. So in other words, client must understand how to interact with them, and has to learn the complex class internally. And then by introducing a facade, then the client code become very simple. You just need to interact with one class, and the facade is responsible for forwarding the request to the package, to the classes within the package. The structure of facade is straightforward. So here you have a subsystem classes, and then you have a facade is responsible for forwarding the request to the classes in the subsystem. Okay. So the facade knows which subsystem class are responsible for request, and then dedicate client the request to appropriate subsystem client, a subsystem object. And subsystem class will implement subsystem functionality, so handle the work assigned by the facade. Okay, so this is the participant and how they interact with each other. And then let's see in what scenario and in what circumstance we use the facade. We see that anytime when you're facing, a complex subsystem, and there are many dependencies between the client and the classes, and so there's a need to provide a simple interface to a complex system. Then you can use the facade, and also facade is a nature structure of a layer. So from here you will see that facade is actually serving, if you have multiple subsystems, and you have for each subsystem you have a facade, and you will see the facade itself become a new layer. So you will see that if you want to layer your system, and then you're actually using the facade. You can see the collaboration. So for the client, you communicate with the subsystem by sending the request to the facade, and then the facade forward the request to the subsystem object. And so this doesn't mean that the client cannot interact with the subsystem directly. So facade just provide an alternative way to communicate with the subsystem. So I mean a simple way for the client to interact with the subsystem. But a client, if they want to, they can bypass the facade and interact with the subsystem directly. So the facade is just provide an an add-on, not a replacement. Then let's go back to our example, our home theater example. Let's look at the source code. And the source code in the home theater facade. So first, the facade declare the instance variable. So these are the component of the subsystem we are going to use. You see that we have amplifier, we have a turner, DVD player, CD player, and so on. So here we have eight instance variables that's corresponding to 8 classes in the subsystem, in the home theater. And then the facade is passed a reference to each component. So you pass in its constructor, and then assign each to corresponding instance variable. So you see that this is how the facade is able to forward the request, because the facade hold the reference, already have the reference to each class in the subsystem. And then let's see the watch movie. Watch movie follow the same sequence as we see before. So here in before this should be without using the facade, then the client will deal with these operations. And now from client point of view is just to have the facade, and then call the watch movie method. Just specify the movie name, and then facade will do the rest. It will forward the request to corresponding the subsystem and call its method. And similarly for the end movie, just from client point of view, just to call one function without involving these operations inside. So similarly for the listen to CD, end CD, and the listen to radio, and end radio. Then let's look at the client code. The main program. And of course, in order to use the package, you still need to instantiate each object within the package, and then you instantiate the facade, and then here you pass all the reference to the facade, and then you can use it. So first you have to create a facade, then use the facade, and then use the simplified interface. You want to watch a movie, now you need to just specify the name of the movie, and then the facade will do the rest. And we'll do the rest. We'll go through the step for you to watch a movie. Okay, let's look at this exercise. So in this exercise, I want to use a facade pattern as a mortgage application object, which provides a simplified interface to a large subsystem of classes, measuring the creditworthiness of an applicant. So the facade has one method is eligible. So here you provide the customer and the amount the customer try to get from the bank. And here, this is eligible. We'll calculate the eligible score, and the score first is 0, and the score will increase by 2 if the customer has sufficient saving and has enough saving amount. Then this number increased by 2, otherwise decreased by 1, and this number increased by 1 if the customer has no bad loan before, otherwise decreased by 1, and then this score increased by 1 if the customer has no bad credit in the past, and otherwise decreased by 1. So you will see that this is eligible will interact with 4 classes: customer, and we'll see the bank and the loan and the credit. So you see 4 classes involved, and then this is eligible is responsible for forwarding the request to these 4 classes. And then from user point of view, it's very simple. Yeah, the user just call this is eligible, and then tell me and tell me yes or no. Yeah, is customer is eligible for the loan or not? So here I want to draw the UML class diagram and the implementation. So this exercise, I will give you 10 to 20 minutes. Yeah, please pay attention to our class exercise, because in our meeting exam, I received so many email complaining no enough time to finish the exam. I think this, I listed 2 reasons in the announcement. The first one is the handwritten note will help, and obviously many of you didn't have that, because I didn't require that, because I cannot have this face-to-face exam. In a face-to-face exam, I ask a student to show me your note so that I know that you are using the handwritten. That's a way to force you to get familiar with the the pattern. And the second way is exercise. Since this is a remote way, I cannot overlook that how well you do the exercise. So this totally depends on you. So please spend time on the exercise. That will benefit you, and that will help you to better prepare for your final exam. Okay, you draw the UML class diagram. You can use your hand, and using the tools I provide, Enterprise Architect, and also have an online tool you can use to draw the UML class diagrams. Try to get familiar with the tools so that you can draw the class diagram faster and writing the code. Okay, so I will give you 20 minutes working on this. Okay, so when you're working on the exercise, you can pause the video. Okay. Now suppose you already okay. Let's wait a few minutes. Okay, suppose everyone is back, and then I will give you my solution. So here we see that we have 4 classes involved: the credit, customer, bank, and the loan. And on top of this 4 class, I create a mortgage facade. So you will see that this mortgage facade as an instance variable. Let's hold a reference to these 4 classes, and then contain only one method is eligible. And so from client point of view, it's just create these 4 classes, and then create this the object of the mortgage facade, then call this is eligible. Okay. Let's see that first. These are all the components in the subsystem. Yeah, we have a loan, credit, bank, and a customer. And this facade is pass a reference to each component in the constructor, and then assign to each corresponding instance variable. Okay, so this is very similar to our home theater example. Then let's see the core of this application is the is eligible. Yeah. So here we provide the customer, and then have the loan customer try to get from the bank. And here is the first requirement. Here to see if the customer has enough money or not. So here to calculate this score, you will see that it will call the banks. Yeah, bank has a method called has sufficient saving. Yeah, and provide the customer and the loan amount. So you will see that it will use the bank. Then to calculate if it has a better credit, it will interact with the credit. I mean the credit class, and the loan, it will interact with the loan class. So let's see that. So you will see that this yeah, this is eligible is interacting with 4 classes. And then of course, if the bank return positive, then the score increased by 2, otherwise decreased by 1. And similarly, if this one return yes, then decrease by 1, otherwise increase by 1. So if this one return yes, decrease by 1, and or otherwise increase by 1. So eventually, after all this calculation, after you have all this calculation, then if the final score is larger or equal than 2, then return true, otherwise return false. Okay. So let's see they're one by one. Let's look at the bank. So how bank calculate if customer has enough money? So here you provide the customer and then provide the amount customer try to borrow from the bank. And first we check the customer. Yes, since here you pass customer to the has sufficient saving. So here the customer, you check the customer saving amount. If saving amount is larger than the amount try to get from the bank, then return true, otherwise return false. Okay, so the bank has this method, and this is how you get from here. So here you provide a customer, provide a loan amount, and then this will forward the request to the bank class, to this method. And then let's look at the credit. So here first, so for has better credit, you provide a customer. First, we check the customer history. If customer has better credit, so here when you create a customer, you already specify if customer has better credit or not. So here, so that this has better credit, we'll first check the history, and then we'll also check if customer have, the saving amount, if less than 1,500. If these both condition meet, then return true, otherwise return false. So in other words, if even customer has a better credit, but if a customer has a saving amount more than 1,500, it still return false. Okay. So similarly for the loan, so here the customer will provide the history of the loan, and then we're also checking the saving amount. If both conditions are met, then return true, otherwise return false. So for the customer, you will see that the customer, when you create a customer, you will specify the name and how much the customer has in the saving account, and then provide the Boolean variable has better credit and has better loan. So here, when you create a customer, you already specify this information, and then this class interact with loan, credit, and the bank, and with the help of the facade, and then it will calculate. So you will see that actually the connection, the connection among these 4 classes are quite complicated. So as a customer, you don't want to get involved. As a client, you don't want to get involved how they interact with each other. What you need to do is just specify the customer and then call the is eligible. Okay, so this is the client code. You create a customer. Of course, you need to create a customer and create all the object within the subsystem, and then you just call this is eligible. You call this one method, provide a customer and the amount customer try to get. Okay, I think that's it for the facade pattern. And the second pattern is the proxy pattern. So proxy pattern is one of the most used pattern, and this one, yeah, is like the adapter pattern is another often used one, and the proxy pattern is also a very often used one. And this one provides a surrogate or a placeholder for another object to control access to. So anytime when if you figure out there's a need to control access to certain object, then you can think of using the proxy. Yeah, using the proxy, and there's a number of reasons why we need to have the control of control access to certain objects. So there's many reasons why you can you try to reduce the cost. You want to have some security issue. So there's a number of reasons why. So here let's look at different scenarios. Yeah. So here, let's look at the motivation. So we know that a proxy is a person authorized to act for another person. So it's like a medium. It's like an intermediary between the client and the target object. So it will take the structure like a client. So the client need to communicate with the real object, but instead of communicating with the real object directly, we have a proxy in between. And of course, from client point of view, client may not realize it is he is dealing with a proxy, because the proxy has the same interface as the target object. So client I just send a forward. Send the request, and then the proxy take the request, and then we'll do some examination, and then forward the request to the real object to get the job done. And then from client point of view, it's just like I just send the request, and then I get answer. So as for this proxy in between, it's not client's concern. Okay. So for the proxy to forward the request to the real object, and then the proxy need to hold the reference to the target object, and then forward the request. Yeah. And I see different scenarios. As I mentioned that before, the proxy is between the client and the real object, and the proxy will control the access to the real object. Then we'll see there's different scenarios of why we need to do that. Why just give the client direct access? So we'll see different scenarios why we need the proxy. And one of the reasons is to save the cost. Yeah, let's look at one concrete example here. Suppose here we have a document editor that embed a graphic object in a document. So think about Microsoft Word document. Okay, if the Word document contain a lot of like the graphic or picture, and then this will make the size of the document very big. So we know that creating the graphic object is quite expensive. Yeah, it's not like the text. So text is very easy. We'll just need a very little memory. However, the graphic object need a lot of memory, so it's expensive. However, we still want to open a document fast. So if the document is very big in size, the open document will be slow. However, even the size is big, we still want it fast. So this sounds like a contradiction. Yeah. So this is like a so in order to achieve both, we can create expensive object on demand. So in other words, when we first open a document, we don't open this graphic object. Yeah, we don't open this object. But when you scroll down to the page that contains this graphic object, then this object will be loaded. So this means in the very beginning, when you open a document, we just open the text. Yeah, this graphic object will not be open, so that it can open really fast. So from user point of view, okay, I click on the document, and then document open, boom, yeah, fast. However, this graphic object is not open yet. Then if you scroll down to the page that contains the graphic object, it will be loaded. So from user point of view, it achieves both. Yeah, open fast, and then when I go to the page and the graphic object is there. Okay. So if in the beginning, when you open the document, if we don't open this graphic object, what we should put in there, then we should, that object is called the proxy. Yeah, it's just in most of cases, it's just a gray area with the same size. Yeah, with same size. However, it's a replacement. We are not using. We are not putting the real picture there. We just put a gray area there. So the solution make the image are stored and loaded separately. And if a real image is now loaded, and then we put a proxy image display a gray rectangle, in place of the real image. So we have a proxy image, and when the user scroll down to the page that contains the image, then the real image will be loaded. Okay. So this is the design. Here we have an image interface. Here we have a image proxy and the real image. So in the beginning, the image proxy is loaded, and then when the customer scroll down the page that contain the image, then the real image will be loaded. Yeah. So the both proxy and the real image, they share the same interface. So from client point of view, the client is not aware of, the real image is not the real image at the very beginning. So that's a scenario one, to save, to load expensive object on demand. The second one is a cache. So here is the ISP internet service provider noticed that many of the clients are frequently accessing the same web page. So here, and this will cause that multiple copy of the web document being transmitted through the server. So here, in order to avoid the multiple copy, then the ISP can just cache a recent access page. So when client request arrive, the server can check to see if the document is already there. Yeah, if the document is already in the cache, then just return the cache. You don't have to, get a new copy. So the cache act as a proxy. Yeah, so in this case, the cache is a proxy. So if you're using the web browser, you will see that there's a function to clear cache. So you see that your local web browser also using the proxy. Yeah. So if it will save the picture, so that when you load the same page, you will see that a lot of picture is already in your cache. Then the page will be loaded really fast. So you will see that this cache is a widely used proxy, not just for ISP but also for your local web browser. Okay, let's see when we use proxy. So in last two slides, we show you two scenarios. Both are used to save the resource. So the proxy are used for whenever there's a need for more sophisticated reference to an object than a simple pointer or simple reference can provide. So this is, ensure that anytime if you see that there's a need to control the access to real object, then you consider using the proxy. Yeah. Okay, let's see more details. Okay, how we different scenarios. One is the remote proxy. If the provide a reference to an object located in a different address space. Yeah. So you have a local representative of a real subject in a different address space. So here, that if you want to access to the object remote, in other network space, then we call it remote proxy. Virtual proxy, just like our scenario 1, allow the creation of a memory-intensive object on demand. Protection proxy provide different client with different level of access to a target object. So in our access 1, you'll see that. So you'll see that if you want to have like a different user have different access to the same object or to the same subsystem, and then you have a gatekeeper. So that one we call the protection proxy. And smart reference provide additional action whenever a target object is referenced. For example, like a load balance. Like we're counting the number of reference to an object so that you can optimize the reference and to balance the load of the object. So this is we call it smart reference, and this load balancer is also widely used. And the cache proxy provide temporary storage of a result of expensive target operations so that the multiple clients can share the result. And go scenario 2, we already show you that we have the cache proxy. So you'll see that so this give you a different type of the proxy. Then let's look at the from design point of view how we design the proxy. So the design itself is quite straightforward. So here we have a real subject, and then we have the subject defined interface of the real subject, and then we have the proxy. Proxy share the same interface as the real subject. So the client interact with the proxy first, and then proxy will forward the request to the real subject when proxy believe it is it is necessary. Okay, so the client will not interact with the real subject directly. Will interact with the real subject through the proxy. Okay, let's look at the how we implement that general structure. So here we have the subject. We have the subject define the interface, for the real subject and the proxy. So the proxy, the real subject will do the work, contain the work that do it, and the proxy will forward the request to the real subject, and then they have an additional code here. So the client will call the process do it, and then this additional code contain all the intelligent, and it will decide to forward the request or not, and when to forward. So this code here will do the judgment. Okay, let's go to our exercise. So here is a this exercise is a protection proxy. The real client class store account number, and only users who knows a valid password can access this account number. So the real client is protected by a protection proxy, which knows the password. So here, if a user wants to get the account number, first the proxy asks a user to authenticate. Only if the user enters a correct password does the proxy invoke the real client to get the account number for the user. So here you draw the UML class diagram and then implement. So here I will give you 20 minutes to work on your own. Draw the UML class diagram and then write the code. Okay, so I guess you already paused and you already unpaused the video. Then let's look at the solution together. So in here, we know the real client contains the account number, and then this proxy will take the action to protect this account number by asking the user to enter password, and they both share the same interface, and this interface has only one method, get account number. So the client will call this get account number, and of course first will get to this proxy get account number, but this get account number will first validate, won't just return this account number as it is. It will ask a user to enter password. So let's see the interface just define the method provided. And then let's see the real client. Real client contain the number. It has only one method, just get account number, and of course the user doesn't have direct access to this method. Yeah. And then let's see the client. I mean the protection proxy. Let's see the proxy. So here, so when you create a proxy, you already specify the correct. You already specify the correct password. Yeah, so this is a password, store in the proxy. Yeah, and then the get account number, and then this one is defined by the interface, so the user will have access to this one. And then you first ask the password, and then once the user enter the password, and then you check if the entered password is the same as the password assigned when you first create this proxy. Yeah, you see if they're equal. If they're the same, then you forward the request to the real client to get the account number. Otherwise, you see the illegal password. So from here you will see that the concept behind the proxy is you have this if statement. This if statement is for the proxy to make a decision, either forward the request or deny the request. Okay. And then this client code, when you create the proxy, you already specify the correct password, and then the client will call the get account number. It will actually go here to ask a user to enter password, and then you compare if the password is identical with the password you assign when you first create this proxy. Okay, we are done with all the structural pattern. Then we'll move to the behavioral pattern. Okay, so the rest of the lecture will focus on the behavioral pattern. Today we were just working on one of them, chain of responsibility. So here still give you the overall, the differences of three type of patterns, creational pattern dealing with instantiation process. So when you create a new object, you don't want to just simply new. You use the keyword new. There's different ways to create, of course, for different purpose. And the structural pattern is dealing with couple and decoupling the structure, and the behavioral pattern deal with the communication. Communication between the object and the classes. So here still we have two approaches, either by using the inheritance or by using the delegation, the composition. Okay, let's see the chain of responsibility. First, let's look at the intent. So here, you try to avoid coupling the sender of a request to its receiver by giving more than one object a chance to handle the request. So usually we know that when we send a request, you have a sender and then you have a receiver. Okay, so in this case, so when we use a chain of responsibility, if you have a multiple potential receiver and you don't know which one will actually take your request, then you can use the chain of the responsibility. Yeah. So here you can first you chain the receiving object, and then pass the request along the chain until one object handle the request. So from user point of view, even you have a multiple object may dealing with the object, but from user point of view, just send the request to the first one in the chain. Yeah. So the responsibility of handling a request is given to any member of a chain. If the first link of a chain cannot handle the request, it will pass to the next and then to the next until one object answers the request. By using the chain of responsibility, we know that the client will send the request to the first one we call the handler, the first handler in the chain. So in other words, the client doesn't have the direct reference to the object that actually answer the request. So this by applying this chain of responsibility, we decouple the client and the handler. Yeah. Let's look at one concrete example here. Suppose here we have the mail server, and the mail server has has a filter we call a spam filter. We'll handle the request first, and then we'll see if the message is a spam, then the request goes no further. Otherwise, if the message is not a spam, then the message is passed to the message handler, and which will store the message. So you will see that from user point of view, I just send the request, I just send an email, but in reality, in the mail server, it will go through this chain reaction. Yeah, first is a spam filter handle, and then if the spam filter, pass it, and then to can forward the request to the messenger handler. Yeah. So in here we see that we have two handlers, spam filter and the message handler. So from client will just send a request to the chain, and of course before we do that, we need first to assemble the chain. So which one will answer the call first is a key in here. In this scenario, because we want a spam filter to answer the to screen the request first. So the spam filter will be the first one to handle. And in some case, in the chain of responsibility, the order, the sequence is that, it doesn't matter. Then you can assemble the chain without considering which one go first. But in this particular example, the spam filter must be the first, must go before this messenger handler. Then let's see how we assemble the chain. To assemble the chain, we have this method called set successor. And since all the set successor is the same for all the handler, then we can just implement once in the handler in the abstract class handler. And then spam filter is a handler. So in here, the spam filter will first check the message. If this is spam, then it will go further. Otherwise, you have passed the message to the next handler. To do that, first we will check if the handler has a successor or not. So in other words, we'll first check is am I the last one in the chain? If I'm the last one in the chain, then I cannot forward the request to successor because I have no successor. So here, in order to do that, I need to first check if I'm the last one. If I'm not the last one, then I forward the request to my successor. Okay, so did it show you the client code, and then the client needed to assemble the chain to set up the chain. So the spam filter is the first one. And then how we set up the chain. So we h1 set successor h2. Yeah, since h1 is a we see that h1 is a handler, and the handler has this set successor method. So you can just inherit from the handler, so that the h1, the spam filter, has a set successor method. It will set h2, the message handler, as its successor. So here we see the chain is h1 to h2. Okay. And then the h1 will handle the request. So if the message is not a spam, then h2 will handle the request. Then here give you one in what circumstance we use chain of responsibility. So here more than one object may handle a request, and the actual handler is not known in advance. Then the chain of responsibility is a natural choice for this scenario. And one request follows a handle or forward request mode. If you sense this mode, then you will also consider using the chain of responsibility. And here shows that the structure of chain of responsibility is quite straightforward. So here you have a client, then you have a handler, and the handler will implement this set successor method. So you will see that's why it has a reference to itself, because it will implement set successor method. And then it has a handle request. Yeah, this handle request, and then each concrete handler will has his own handle request. Yeah, in order for the whole structure work, the client code or some other code need to assemble the chain first. Then you can use it. So you need to first set up the chain. Yeah, is by calling the set successor and set up the chain. Then you can use this. Then you can use them in a sequence. Okay. Okay, let's see the consequences. Yeah, by using the chain of responsibility, what do we got? First, of course, the first advantage we have, we reduce the coupling. Yeah, because the sender doesn't know who is the actual receiver, so we decouple. Yeah, we decouple the sender and the receiver, and also the receipt is not a guarantee. So the request may fall off the end of the chain without being handled. That's also possible. And we have flexibility in assigning responsibility. So the chain the setup of the chain can be modified anytime you want. Let's working on this exercise. In here, a company goes through different approval level to handle purchasing request. The approval authority depends on the dollar amount of the purchase. So there are 3 levels. So the program manager can approve purchase requests less than 50,000. And the manager can approve the request more than 50,000 but less than 1 million. So if there any purchase request more than 1 million, then the COO is the one who approve it. So here I want to build a chain. So here I give you the chain sequence. First, the program manager, to check with the program manager. Your program manager can handle it, forward to district manager, and then eventually, the last one in the chain is a COO. So here I want you to provide UML class diagram and then provide your code. So here I still give you like 20 minutes to working on both, working on class diagram and the code, and then please pause your video and then come back. Okay, so I suppose you already finished and you're coming back. And in here, we have the purchase handler. And here we have 2 methods. One is handle request. And of course, this one, you provide the amount to be verified. And then we'll also implement this set successor. And then we have 3 handlers: program manager, district manager, and then we have a COO, and each will implement this handle request method. let's look at the purchase handler, and let's look at this abstract handler. We are just implementing one method, set successor, and this will be shared by all concrete handlers. And then program manager will handle the request less than 5,000. You will see that you give the amount that's being verified. If this one is less than 5,000, and of course this one the purchase manager will handle it. Otherwise, if it's more than 5,000, it will check if it has a successor or not. If it has successor, and then forward the request to the successor. So similarly for district manager, all the code is the same, except it's the first if statement. Yeah, the first if statement here is less than 5,000, and this if statement is showing up more than 50,000 but less than 1 million, and then forward to the COO, forward to the next successor. The last one is the COO, of course. Yeah, is more than 1 million, and then it will handle. Yeah, so here is still, yeah, if this one if is if doesn't satisfy the if statement, if I also check the success in our scenario, we know that he's the last one, but here just in case, in the future, if you want to have more people involved, then I mean behind the COO, and then it may have a success in the future. So here just give you the flexibility you want to, if you want to change, you want to set up the chain differently, or you want to expand the chain. And here is the main program. So here we first set up the chain. This shows you how we set up the chain. So here the program manager is the first one, and its successor is district manager. District manager's successor is COO. So this is how you set up the chain. And then you have the request, you have this for loop to go through this one, and of course the program manager is the first one in the chain. So you need to give the request to the program manager first. And this will be the output showing you who is handling the request. Okay, I think that's all for today's lecture part. And today I also assign your project 2. So this is your project 2. I already post on the Canvas. So the project is due, so you will see that 2 weeks from today. And consists of 2 problems. The first one, I want to the problem demo use the use of the chain of responsibility (COR), and here I want you to have this length converter program we call the LCP, but this program must come with a GUI. So here the LCP will perform conversion from kilometer to one of the 3 unit, mile, yard, and foot. So in here, the user will enter the kilometer, and then user can choose, which unit to be converted to, the mile, yard, and foot, and then click on the convert, and then it will provide the result. Yeah, for example, like 10 kilometer, if you want to convert to a mile, is 6.21371 mile. So here I want you to use this chain of responsibility, and this is how you set up the chain. Is a mile first, mile, yard, and the foot. Okay. As for which one to use, I mean it is up to user. A user will make the choice here, and then your program will follow the chain, and then based on the user's choice, then the corresponding handler will handle the request, do the conversion. Okay, so your program first is the amount in kilometer, and then the first handler is a mile, second one is a yard, and the third one is a foot. As for which one actually handle the request depend on user specification. Okay. So deliverable, I want to provide a UML class diagram, and then a single Microsoft Word document containing a screenshot of different scenarios. So here we have a 3 scenario: mail, yard, and food. And then you have a printout of your source code, and also provide the soft copy of your code. So here, you have two copy of the code: the code in the Word document, and the code in your directory, in your implementation directory. So here, just in case, I will first look at your Word document, read your code. If your code makes sense, I probably don't have to go to compile your code. If I see there's something I need to compile your code to check your code in further detail, I need your code in your directory so that I can do the compiling and then run the program. The problem 2 also involve a GUI, but here I want to I want to integrate decorator pattern into this chain of responsibility. So here, suppose that you have the result, you have the converting result, and then I want you to apply these 3 decorator to the result. So first, you round to the second decimal, and then you write output in the exponential notation, and then you add the unit name. Yeah, that for example is yard, then you attach the yard. So you'll see that this conversion will go through these 3 declaration. So in here you have first you go through 3 handlers, go through the chain of responsibility, go through the 3 handlers, and then the result will go through these 3 decorators. Yeah. So here you will figure out a way how they connect. That's your responsibility to make sure how they connect, because the difficulty here is you don't know which one actually handled the request. Yeah, but you still then you need to find a way that for the result being given to the decorator to go through these 3 decorations. So still, you for the problem 2, you have a UML class diagram and a single Word document, and also the soft copy of your code. So please, in here you have a 2. You have problem 1 and 2. Please zip everything in one file. Yeah, in one zip file. Yeah. So I assume that you will have 2 folders: the problem 1 folder and the problem 2 folder, and then you just zip both folder into one zip file and then submit on Canvas before the due. Okay, so if you have any question, you can you can come to my office hour, and then we can discuss. Okay, I think that's it for today, and I will see you next week.